A very good afternoon to everyone. The new attack vector came very recently, November 24th. So it's barely been like 1.5 days. And this session is an attempt to share some knowledge. So if you haven't read any of the reports, it's going to be totally fine because we are going to pretty much slowly go into more complex topics. We're going to start from the basics. So first thing is this is the NPM related supply chain attack. So the question was, what is NPM? NPM stands for Node Package Manager, which is the world's largest software registry. It's basically used in every continent. Developers share and borrow packages. And many organizations actually use it to manage private development as well. And it includes a public registry of over 2 million packages. So that's a huge number. Question is very interesting. Who owns NPM? So actually, GitHub, which is a subsidiary of Microsoft, acquired NPM in March 2020. So indirectly, NPM is owned by Microsoft via GitHub. A lot of people don't know that. NPM has three main components. The website, so you go to npmjs.com, where you can discover packages, you can set up profiles, you can manage other aspects of your NPM experience, create tokens, you can create organizations, you can give access, and so on. And then you have the command line interface, which runs from the terminal. And this is how actually most developers interact with NPM when they're publishing packages, making changes, and so on. And the registry component is the largest public database of JavaScript software and the meta information surrounding it. There are three components of NPM: the website, the CLI, and the registry. This is actually how the site looks like. If you look at the left, these are the popular libraries. You can discover packages. It can be front end, back end. You can also find documentation. And the right side is really amazing, which is you have huge amount of packages. And if you just look at the amount of downloads last week or last month, you can understand the scale of this thing. So this is literally one of the key components how software development works, especially since everyone uses a lot of open source libraries. So basically, for accessing via command line interface, NPM has this concept of access tokens. So if you see on the left, you can create organizations, you can create users under it, and you can create access tokens. So in fact, these are the access tokens, which if stolen, can be used to publish unauthorized packages. Question, what is Shai Hulud? So it's an NPM supply chain attack. It leverages temporary compromise NPM maintainer accounts to publish trojanized versions of legitimate packages from major ecosystems. It's actually named by the attacker himself, based on the sandworms in the movie Dune. It appeared in the NPM space in around mid-September. It compromised 187 packages with a self-propagating payload. So again, if you see, the number is still small, and as compared to Shai-Hulud 2.0, it's already 803 packages. The payload used the TruffleHog secret scanning tool. And that's the case with 2.0 as well, that there are 3-4 ways that it gets the secrets, and using this TruffleHog secret scanner is one of those ways how it gets those credentials. It's fully automated, self-replicating by the nature of it being warm, that it can propagate by itself. There's no human intervention or attacker intervention required. Once it infects the machine, it can go on, and we'll talk a little bit into detail how it does that. The key point is that there is a malicious pre-installed script which gets installed with these packages. So when you install this NPM package, this malicious pre-installed script will execute automatically during installation. What it do, it basically got developer and CI/CD secrets, GitHub, NPM tokens that we talked about, secrets for cloud platforms, and we'll see it again. Basically, from a coverage perspective, it covered all three very specifically. So it has specifically SDKs from all the three cloud platforms so that they actually read the secrets from them, because all these platforms have a different way of how they manage secrets, and the worm had the exact code to be able to read those credentials. The other interesting thing was that credentials were being uploaded on GitHub, and it was not necessarily in your own repo. It could be a random repo, and these would be published. And the name of the repo was random as well, which is, it was not something specific. So people are discovering that somebody has posted somebody else's credentials in their GitHub repos. They have created a public repo and posted in their GitHub account. And this happens, and we'll talk a little bit more about that, how it actually gets installed and executed. So there is this concept of lifestyle scripts, and this is how it basically that gets installed. And the timing is also very interesting. If you go to npm.js, they actually have a deadline for revoking old tokens on December 9th. So this is November 24th. So the timeline is also very interesting, that why this is happening now, just before the deadline for revoking old tokens. And I think the most interesting thing, and which sets it apart, is that there is two new payloads, and this is very important. Setup_bun.js. JS is JavaScript, and we'll talk more about what is this bun thing, BUN. And the second one is called bun_environment.js. So these are the two key files in this attack. It's very important to keep note of this, that these are one of the key things which are important in this attack. So bun is not an acronym. It's actually an all-in-one JavaScript, TypeScript, and JSX toolkit. And it does multiple things. It's like it's a JavaScript runtime, it's a bundler, test runner, and a package manager all built in together. And it ships as a single dependency-free executable. It's basically, you install it, but then you use the setup_bun.js to execute the actual malicious file, which is bun_environment.js. So this is the actual malicious code. It's pretty big. It's 10 megabytes. Usually malware is not that big, because if you have larger size malware, it can actually get detected. So it's fairly big, and it's being analyzed by a lot of application security vendors in detail. I looked at the code. It's fairly interesting, fairly complex, and elegant in its own way. It does rely on extreme obfuscation techniques. There are a lot of ways they have tried to obfuscate it, and it contains a significant amount of built-in logic for information theft. Since this whole thing is around stealing credentials, they have gone to a lot of detail as to how we do go about. And again, we'll go through the entire logic flow in the coming slides. As we talked about earlier, a randomly named repository is created rather than a hard code name. It's totally random. There's nothing you can search for in terms of signature. It infects up to 100 npm packages as compared to the 20, which was the Shai Hulud 1.0. And the key and the interesting fact is that it used GitHub Actions as an automation and persistence layer. So automation, that how do you go about executing tasks, and persistent layer is how do you actually stay in the environment, in the dev environment, so that the attacker can come back and have a backdoor inside your environment. And another interesting thing which Shai Hulud 2.0 has, it has a disruptive stub, also called like a dead man switch. And basically it wipes all the files in a victim's entire home directory if exploitation is unsuccessful. So this is very interesting, which is, oh, I was not able to exploit and get the credentials, so I'm going to delete everything. But again, it happens only when this set of 4 conditions are met. So one, if the malware cannot authenticate to GitHub, it cannot create a repository in the platform, it cannot fetch a GitHub token or find an NPM token. So literally, if it can't do anything, then say, hey, I'm going to destroy and delete everything in the home directory, everything in the victim's home directory. Okay. The question is, how did it all even get started? That's not true. The first compromise happened via phishing or social engineering campaigns. But even for a worm to start, first you need to have the first victim or patient 0. So that was done through traditional phishing or social engineering before the worm got installed and you had victims and it started propagating. So the first one was through traditional phishing or social engineering campaigns. Timing is very important. So per security researchers, these packages were uploaded between November 21st and 23rd. We started seeing the malicious packages from 24th, but the actual uploading happened 2 days before, 21 and 23rd. And in the first one were coming from async API, then it was from PostHog, then it was Postman, and then so on. initially, I think we'll talk about the exact beacon it started publishing in these GitHub repos in the description. And pretty much like just today morning, they changed the repository descriptions to advertise this thing like free AI at APN or Air Force. And there is a link to Discord. So as we said, a lot of popular packages with millions of downloads are impacted. Postman, Zapier, ENS domains, PostHog, browser base. So as per some of the application security vendors, the list is 803 right now, and maybe it's going to increase in a few days. 25,000 repositories tied to 100 of developers have been affected. So these are like NPM maintainer accounts, people who maintain these NPM packages. But then if you install, then you also become a victim. So looking at the scope, literally the Zapier has an official toolkit for building Zapier integrations that got compromised. ENS domain packages, and this is a set of tools and libraries which is used by wallets, DApps, and exchanges. So there's a financial incentive, like why ENS domains and not somebody else. Postman had 17 packages from Postman with 51 versions published. So again, there's a blog post from there which they have removed the malicious versions and they have put clean versions now. But if you look at the scope of this thing, this is huge. And just to prove that you don't have this, I think there's going to be a lot of work, even for security, dev and DevOps teams, to ensure that they don't get impacted. So maybe you didn't get impacted, but you have to prove it to the management and to your engineering leadership that we didn't get impacted and that we don't use Zapier anywhere, we don't use Postman anywhere, especially in a large org, multinational, with thousands of developers. This is going to be a very interesting / painful exercise. Impacted repos. So you can actually search for them. If you use this keyword, Sha1-Hulud The Second Coming, full stop, you can actually search it, and you can do it like right now. If you go to GitHub, you can search for it. So when I did this, it was showing 9.6 thousand results. The question is like, why would the attacker do it? Like, why leave a trail per se where you can actually identify if the intent was to be stealthy? Why would you do it? Like literally you can go and search for it now and it will tell you. So one of the reasonings is that the way it has been written, that actually the code can search public GitHub repos and it actually looks for this beacon phrase and it's able to self-heal. And one of the application security vendors has done a good job and explaining like how this process works in technical detail. But there is an intent behind it. So it's not random that this person was showing off. There is a actual code in the malware which will search for public repos and will look for this exact beacon. And this is actually the description of the repo. When you say Sha1-Hulud The Second Coming, this keyword has been written in all these compromised GitHub repos. So this is how the chain of attack looks like. And again, this is like typically how a worm would work. Abuse NPM, compromise GitHub repos, infect developer and CI systems. So basically this thing compromises not only CI/CD systems, but also developer workstations. Use automated workflows, GitHub Actions to propagate itself. We'll talk more in the coming slides, the exact logic behind this. Steal secrets. So the whole intent of this thing is to steal secrets for nefarious means. And we'll see some examples of if you steal secrets, what can you do? And then once you have stolen secrets, you can pivot into other environments. So you steal secrets from one environment, and then you can pivot to lateral movement and so on. One interesting question was, and I didn't see anyone talk, and most of people are saying we don't know who did it because definitely someone launched the first version. So who did the second version? So again, according to AppSec vendors, no attribution has been confirmed. And again, I did a thought experiment and I fed all this information into Google Deep Research. And this is, again, this is not me, my conclusion. It's actually coming from Google Deep Research. What it told me was that depending on, there's a convergence of financial targeting, especially with the ENS domains and the malware signatures used, which is Rustdoor and Stealer, and the way previous campaigns have worked. They think, Google Deep Research think that it's the North Korean Lazarus group, specifically its Blue North subunit. So again, I don't know a lot about this unit. So I think, again, a good research point to understand what other campaigns this group has run, and are they similar to Shai Hulud 1 and 2.0. Okay, so once you have these compromised NPM, what are you going to do? So one is credential harvesting, that you can get GitHub personal access tokens, also called PATs, the NPM access tokens that we saw in the first slide, API keys for major cloud providers. Then once you have access, you can monetize it. You can steal data, you can deploy ransomware. Literally, if you have production access, you can steal data. You can say, I'm going to encrypt the whole thing and say, now give me money. Or you can just make it part of your crypto mining farm, or get data out if there's essential financial data or PII kind of information, or maybe it's intellectual property which the company is working on. Or it could be source code espionage, because the malware was also designed to make private GitHub repos public. So literally, if your code is open to the public, then people can find vulnerabilities into it. They can look how you do business and so on. Once your code, which is confidential, is out there, then there are a lot of risk factors involved, including people finding vulnerability in the code, apart from business logic, that how you do business. Again, the one other interesting thing was that the way it was designed to establish persistence. So it was not that, oh, I'm going to do one thing and I'll be gone. One of the aims of this Sha1-Hulud 2.0 was that not only I'm going to steal credentials, but I'm also going to set inside the environment for future. So it's like literally like a backdoor access for future, which can be used to do other nefarious things. So now I think we'll go a little bit on the technical details of the attack itself. It happens during the installation lifecycle. It targets both CI/CD runners and developer workstations. It's not just for your dev environment production, but it's also the actual workstations. These endpoint companies, the CrowdStrikes and the Sentinel ones of the world, they can look for key artifacts. And we'll talk about the artifacts which get dropped, including the two .js files. Detection at the endpoint level, either on the server side or on the endpoints, can be done using these endpoint companies, but I haven't heard anything from these companies. So this is how the attack begins, that you have this entry in the package.json, which gets installed. That's a node setup bun.js. So this is one of the files that we talked about. It gets entries made. And then it checks whether bun is already available in the path. Bun is used to execute this file. And if it's not found, then the bun installer is actually installed. So this is again very interesting that it says, is the installer there? Not, then it actually gets installed directly. And then reroll happens, then the actual payload is executed in the freshly installed bun runtime. Okay. So now we'll talk a little bit about this file, bun_environment.js. It's pretty big, 10 megabytes, extremely obfuscated. And there's a massive hex encoded string array containing thousands of entries. There's an anti-analysis loop at the very top, performing millions of arithmetic operations. So I think this makes it clear that this is someone which is fairly sophisticated. This is not like a simple attack. It's very well thought out, done by a group extremely good at programming, and they have been at it for a while. Every string in the code is retrieved by an obfuscated function. There are other ways to hide. So for example, it will fork itself in a background process, and the terminal will just return instantly. So you will not see something executing at the terminal level, because sometimes, for example, you download or you do some actions, certain text in the terminal, but that not happens here because the terminal will return instantly. So you're like, oh, it happened. And this is again very interesting. Official SDKs from AWS, Azure, GCP are bundled, which means that the host which is being compromised doesn't need to have these SDKs, which kind of points to the sophistication of these attacks, that this person knows how to work with these three environments. So talking about the core logic, so it actually checks for the major CI environments. So check for GitHub, actions, it checks for GitLab, it checks for Travis, and it checks for Circle CI, which also means that if you're not using these major five, maybe you are protected. But again, 95% of the world uses one of these. But again, this is the code in the actual malicious payload. And this AL0 function is also very interesting. So it's used to run full exfiltration. And the question is, like, what is this AL0 thing? So we'll talk more about AL0 in a bit. In this code, if you see, it says bun.spawn. So basically a background process is being launched. So bun.spawn. If you come in a bit below, it just returns very clean. The user will not see anything suspicious. And we'll talk about AL0 in a second. What's the impact? The dev environment is compromised. The TruffleHog, which comes pre-packaged with this malware, is used to scan for passwords, API keys, cloud tokens, GitHub personal access tokens, or NPM access tokens. And again, this artifact, that where is this binary coming from? It's coming from .truffler.cache. Again, these are a lot of our signals and artifacts which are going to be used by different vendors to detect that is your machine compromised. So if they can find a way that TruffleHog or this cache exists, that means you're compromised. So coming to AL0, so basically it's used to orchestrate a full spectrum theft. You get the person access tokens, and this is the exact file where you get it from. And this is the exact location you get it from, .netrc. And then the malware fingerprints the host. So again, in the coming slide, we'll talk about what exactly is fingerprinted. It scavenges the cloud vaults, scans for secrets, and everything is exfiltrated as JSON blobs. So it serializes all the secrets and then creates its JSON blob and posts this artifact in a public GitHub repo as this CI artifact. And again, the public repo is named after a random UUID. So there's no particular signature that you can look for because the repo will have a random name. But again, the description remains same, Sha1-Hulud The Second Coming, which is, again, as we mentioned earlier, that it's a beacon for to be used by the worm for self-healing. So there's a purpose behind it. It's not random. So the question is, like, what is this AL0 thing? So it's actually a crypto mining rig, but in this case, it's being used as a command line instruction to launch a payload. Like when people see the code, they're like, hey, what is this AL0 thing? So it has, this whole thing has been repurposed, which again points to that this group of attackers is very familiar with the crypto world and the different libraries, and they used one of the libraries to launch this payload. Questions like, where does it get these credential forms, local configuration files, which you can find in these locations, the environment variables, and the internal cloud metadata service, IMDS. And then basically you can dump secrets from AWS Secrets Manager, Google Secret Manager, Azure Key Vault. So it has support for all three because all these official SDKs come pre-installed and they don't need to depend on the host to have them installed. And as we talked earlier, that these secrets are serialized and written to a JSON file and uploaded in the Exfiltration repository as a CI artifact. And this is the actual name of the file, actions secret.json. So again, all these artifacts can be used for detection purposes, that if you have any of these artifacts, good chance that you are compromised. Talking a little bit about the exfiltration logic. So I think we talked about that it fingerprints the platform. So this is the code for fingerprinting. So if you look, it says platform os.platform, that what exact OS you're running. Is it Linux, Mac, or something else? Architecture is x64, x32, platform details, so pretty much detailed architecture, detailed platform details, the actual host name, the user info, like which context the machine is running in currently. So that was fingerprint entering. So if you look at the second one, it basically, this is the token. So one, it gets the GitHub PAT, the person access token. It says here token.github client.get current token. So you are getting the token and then you're using it. This command is used to dump all the CI secrets. So it says environment dump, environment process.env. So you're dumping all the CI secrets, any NPM tokens, and so on. Then this code is basically you're getting, say, AWS client list and retrieve all secrets, GCP client list and retrieve all secrets. So pretty much you're getting secrets from all the three major providers. In this code, you see the TruffleHog, which is a secret scanner, open source secret scanner, that how this thing works. One, it's auto downloads the binary, it initializes it, and then it exfills the finding. If you look at the number 6, you sniff for the NPM token. If you look at the code, leak full code to npm.json. And the last one is actually very interesting, and we'll talk more about it, is that how this thing is used to bypass data loss prevention tools or any firewall or any egress filtering. Obfuscation is a key feature in this malware. So we'll talk a little bit more about it. Attack proliferation. So these packages are being published at scale. So literally when AppSec vendors were tracking, the number was increasing on the go. So the scale is pretty massive. These can be used, these artifacts can be used to detect compromise. GitHub is actually working on directly on it. They're deleting the attackers' repositories as they emerge. But again, the threat actor is also on their heels and they're creating it very fast. And again, another observation, and not from all AppSec vendors, but some AppSec vendors have detected that if credential harvesting is unsuccessful, Sha1-Hulud tries to do container breakout and prevent the escalation, and we'll talk a little bit more about it in the coming slides. So this talks about how it does it. This is Linux only. So the first portion is Linux only, then the second one is for Docker. So basically it attempts a password sudo, and then if it doesn't work, then it tries to do a container breakout. This is the exact command it runs to gain root privileges. Pretty much password root access to the GitHub action runners. So again, we'll see what role these GitHub action runners have, because this is one of the key features of this malware, that it makes extensive use of GitHub action runners for automation and for persistence. So this tool also does DNS and firewall manipulation. It stops systemd, it replaces DNS configuration, it restarts the resolver. It also flushes the IP tables. So these are the two commands it runs. Not all vendors have caught this. It's going to be very interesting that everyone is still analyzing the code. I'm sure new findings will come out when the whole code is analyzed, because the attacker has done a lot to obfuscate the code. I'm sure when analysis is done, there'll be more findings. So basically, if you do DNS and firewall manipulation, you can exploit the environment. You can do man-in-the-middle attacks. You can redirect packages. You can actually block security scanners. So maybe they find something, but since you have control, you can block the security scanners from reaching the internet. And you can even prevention. For example, vendors are sending security updates, but since you have network level control, you can actually prevent them. I think in the next slides, 7 or 10 slides, we'll talk about, okay, like all this is bad stuff is happening, but what can security teams do from an action perspective? So the first 2 slides are about NPM package providers. So for example, if your company is providing a NPM package, these are the few things that you can do. The first thing is, just like Postman did or other companies did, you have to say, okay, which compromise packages I have in my environment. And you can say which were published in the last 2 days, because November 21 and 22. And so November 21 to 23rd was when the packages were uploaded, and 24th is when it actually the attack happened. So literally you say which packages were changed between November 21st to 23rd and who did it. So the audit trail, And if other artifacts are found, and if this was not done by someone in your organization, then you would pull them off and you publish the clean packages. Customer communication. So again, all these companies are going through a full incident response life cycle in terms of analysis, in terms of forensic analysis, in terms of customer communication. But the two key things is that are their own app or other services are compromised or not. So customers need this reassurance. And this is very interesting because even the security companies will need to do that because they also use the same things. They are not like Postman is like a common tool which all developers use. So very interesting to see in the coming days, communication from all companies, including security companies, whether their own app and services are compromised or not. And again, if npm packages is one thing, but your other production cloud services got impacted or not. And again, it also depends on the motivation of the attacker. This is what exactly wanted to do, or maybe because if you have this level of access where you can actually publish npm and you can do lateral movement, you can go and delete databases, you can delete backups, you can do a lot of harm. But typically financially motivated attackers, they are going after one exact thing and they're not looking to cause mayhem. But again, you have to get that confirmation if your production cloud services are impacted or not, and publish RCA reports. So we'll see a lot of root cause analysis reports coming in the coming week. For users of npm package, so if your company uses any of the npm packages, the first step will be auditing. Do we use any of these major 803 packages which are compromised? And if we use it, did we download in the last 3 days? So November 21st onwards, was any download done, and are they being used in our production environment? So you can literally run this command, npm-ls, to check your installed versions. You can check the package lock, JSON for any compromised packages. In npmjs.com, you have the npm org. So you can see there which npm packages were published and their published date. So you can literally go and check in your own registry under your organization which packages were changed November 21st onwards. And again, if it were me, I would actually look a little bit further to make sure that maybe the last 3 months packages were clean. Second step, so you audited, you know that, okay, my developers did download compromised versions. So you delete old packages, you pull fresh versions, and you can run these commands to remove all node modules. Then you also do cache cleanup. So you can run this command to clean your cache. Then you pin dependency. So it says, I'm going to use this exact packages. I'm not going to update. So either I'm going to roll back to November 21st, or I'm going to pin the known clean version, which has been provided by these vendors. Everyone with me so far? Give me a thumbs up. Thank you. So there are a few other steps you can do in terms of npm packages. You can update your package lock.json file to exclude malicious versions. You can replace your packages, reinstall dependencies with safe versions. You can pin packages, enforce MFA on GitHub and npm accounts, disable npm post-install scripts during CI if possible, and even consider full system reinstallation. So instead of just doing piece by piece, do a full system reinstallation. And also maybe freeze any new npm package updates. So as more npm packages are being compromised, you don't want to download and use a compromised one which just got compromised. So you would put a freeze that till the air clears a little bit, I'm going to freeze any new npm package updates. Credential rotation, this is actually the most important, but is going to be the most painful step. I think for most companies, that's why I was saying that this Thanksgiving is not going to be a happy Thanksgiving for DevOps, and security teams, because security team does own secrets, but they're responsible for kind of project managing this whole thing. So revoke and regenerate. So these were the tokens which were targeted, which were the GitHub person access tokens, the npm authentication tokens, SSH keys, API keys. We saw that the environment files were dumped. So API keys in the environment files, any credentials tied to cloud providers. Again, we saw that the malware actively targeted the secrets for these cloud providers, enforcing phishing resistant MFA. And again, other key point is that when you do all this rotation, you do it from a separate trusted machine. Since the developer's machine might have been compromised as well, you want to do it from a clean machine, probably someone who is not a developer and doesn't have all these packages downloaded and so on. You can also use short-lived scope tokens. So scope tokens is that which you can do only certain things. So you scope what a access token can do, and they're short-lived, so they don't live forever, and you can use them only for a short period of time. So use it for both developer access, and you also use the same philosophy when you're doing automations. Next step you can do is you actually can audit your GitHub account. Since one of the beacons is this description like Shai-Hulud, or so make sure that none of your repos, and you can literally just search, put a search keyword and search if any of your GitHub repos have this descriptor for any of the repos. You can review audit logs. You can also review security events. So this is actually the exact link for your own GitHub account. So github.com settings/security log. You can review for unauthorized workflows or suspicious commits referencing Hulud. And as we said, that one of the ways this malware worked, that it made private repository public because there's some code espionage involved. So make an inventory of all your public repos and make sure they were intended to be public and not private. If they have been made public, make them private and do a damage assessment. You also want to look for privilege escalation and lateral movement, because if any of these tokens, this is literally like keys to the kingdom, a attacker could do a lot of things. They could create more accounts. Maybe there's an existing account and escalate the privileges, or it could do lateral movement, it could just move around your environment, not just sitting in one compromised environment. So again, security teams will have to do a little bit of investigation for any hints of privilege escalation or lateral movement. Getting rid of persistent backdoors. So this attack also did weaponization of GitHub self-hosted runners. So again, this is a functionality which GitHub has provided for automation. So step one is it gets a GitHub Actions runner registration token. And then it installs a self-hosted runner called Sha1-Hulud on the compromised developer or CI machine. And this is interesting. Why did they do a runner with this exact name? And again, there might be some reason I don't know, because they could have literally created this self-hosted runner using an obfuscated name. So just like the beacon, there might be some logic behind why they created a runner with a fixed name. It also, the second way it creates a persistent backdoor is that it adds a workflow called discussion.yaml. And any repo which this code creates have discussions enabled. And we will see an example that how having discussions enabled can trigger a remote code execution by creating a discussion. So there's literally like a public repo, and you can put a comment into that repo, and that comment, if it's a remote code execution kind of attack, you can actually do it. And we'll see the exact example of that code. And this malware also attempted to assume privileged access roles and manipulate IAM policies. So again, security teams will have to review that all their IAM roles, permissioning is all right, any policies were changed. So literally, I would say for the last 3 days, you would have to do a complete house check that if we got compromised, everything is kosher. So this is actually the code example. So if you look in the course discussion, create, run on self-hosted, then the last command is interesting. It says run echo GitHub event discussion body. So basically, in a GitHub repo, if you put a command, which could be anything, this malware will actually execute it. So the echo says whatever is in the comment, run it. So this is literally a single line of code which is causing this remote code execution vulnerability. Mitigations. So again, if your repos don't need discussions, disable them, get tooling. And this is interesting. It could be done manually, or there are a lot of open source and commercial tools for monitoring this. And review changes to IAM policies, November 21st onwards for sure, and maybe go a month back as well. Whether every change is tied to a change ticket or a Jira ticket or some sort of authorization that we are making this IAM policy change, who's making it, why was it made, and so on. Or is some random change without any authorization or approval. So there's no audit trail for it. And again, if you in the prod, no changes go without some sort of ticket or an audit trail. So this is going to be important. This is what's going to keep security team busy in the next few days. Harden pipelines. So basically disabling license, post-install, pre-install, build system outbound network access. So you still want to have it, but limited to trusted domains. Again, so the best practice should have already been done, but use short-lived scope automation tokens. We talked about it. Enforce the cooldown period. Again, you don't want random updates to NPM packages, especially for the newly published one, because there's still a lot of gray area. So typically, the best practice is to wait for at least 2 days. Monitor runtime behavior. And this is very interesting, where it could be done technically manually or using some of the open source or commercial tool that any anomalous install time activity, any workflow creation. So we saw that the malware actually creates workflows. So hey, is this workflow authorized? If you see AWS Key Manager being accessed, you can create specific events and alert on them. Command execution on CI runners. So this is again very interesting, that before it gets deployed, you want to catch it right at the CI level. Known IOCs, as the research starts coming about this malware, then you say, oh, we know these signals and we can look for and prevent. You can build controls around those known IOCs. Any outbound connections. So again, this thing definitely uses command servers. So if we can block those at the network level, any known C2C servers and so on. So these are some, so this is a very good GitHub repo called Awesome NPM Security Best Practices. So you can look it up. It's also in the references documentation, which I provided. I'm going to paste it again. Shift V. So it's right at the top. The references has this awesome NPM security best practices. GitHub actually came with a plan to secure the NPM supply chain on September. But again, they're gradually deploying it, so not everything is done. NPM also came with this concept of trusted publishing, so there are some docs there. So this is the whole plan that they came up with. And this introduces this concept of trusted publishing. And basically, if you implement it, then you don't need to use API tokens in build system, which is huge. And the other interesting thing is deprecating any classic tokens or time-based one-time passwords, or TOTP is time-based one-time passwords, and migrating to FIDO-based 2FA. So again, it could be open source, commercial, or in-house developed. So there are a lot of things that you can use for detection and for monitoring purposes. For example, you can alert teams and packages that are published through unusual channels. You can check for runtime security monitoring, what GitHub Actions is being used, any network calls, file system changes, any unauthorized package releases. These are some signal on IOCs. And again, all the vendors are coming up with their own signals and IOCs. These are some which are like self-obvious, that, hey, bun has been installed or not. That's as simple as checking, because that's the first step to execute those two files. Set up bun.js and bun environment.js. So you can look for these artifacts. As this attack happens, these artifacts get dropped in. So they can be checked whether you have any of these in your environment. And you can check for different functions. So again, the different functions which are being called. We also talked about that a self-hosted GitHub Actions runner was created. So we can check if that is in the base is actually happening. Is TruffleHog running? That's open source secret scanner, which is used by this malware. Any unauthorized recent workflow files, any abnormal repo operations. So examples like high volume repo creation, or repos are being changed from private to public, because everything will leave an audit trail. Novelty, this is designed for stealth. So that was one of the biggest thing, that somebody has taken a lot of time to make sure that this malware is very stealthy. And it actually deletes workflow and branches. So as it does something, it will actually go back and delete so that there's no audit trail. Proliferation, so we're designed for proliferation. This time the scope is increased, is basically targeting all three major cloud providers. It has multi-platform support. So actually it checks whether this machine is a Linux machine, a Windows machine, or Mac OS. And then it has appropriate payloads for each of those platforms. It uses advanced GitHub workflows for persistency. It has different evasion techniques to evade DLPs and egress filtering, because they're using actual user tokens. So these are real authentic user tokens. The DLP or egress filtering has already been allowed to make sure that legitimate actions can take place. They would never catch it. And again, this is a very new feature, the destructive fall behavior or dead man switch, where actually wipes a user's home directory if certain conditions are met. Keep diligent. So again, this is net new, that apart from the NPM JS ecosystem, the Java Maven ecosystem is also getting impacted. The Maven central team has remediated this. But again, it's going to be interesting to see that does this thing go to other ecosystems as well. Conclusion, supply chain security is one of the most critical challenges facing the software development ecosystem. And please do share some love with the impacted teams in org, dev, DevOps security. It's going to be a rough Thanksgiving for many of them. So if any one of you are from any of those teams, this small bouquet from my side to all the work you do. And with this, we conclude our session.